Good evening, students. Hello. Hi, Yadav. Yes, Mamata, Vinayak. Good evening. Hemavati, hello. Yeah. Okay. So in the last session, we started with the concept of light. Alva. So in today's session, we will start the another concept, that is light. We completed in the last session. Problems discussion is pending. So in this chapter also we are going to discuss numerical problems. So ಎರಡು chapter do andre light ಮತ್ತೆ electricity chapter do I will be taking numerical problems in one session. Okay, fine. So electricity. Today's physics topic is electricity, and my dear students, today we have English medium session. Okay, I hope you all are aware about it. Today we have English medium session. In between, I will be using Kannada also. Okay, don't worry. Fine. So electricity anta helidre. For example, consider anything. So you all are attending the classes now. Some of you are attending through laptops. Some of you are attending through computers. Some of you are attending through what I can say is your cell phones or mobiles, right? Then some of you, the lights will be switched on. Okay, mobile charging irbeku. So everything from morning to till sleeping, you are dependent on what? Electricity. So how this electricity is formed, how it is generated. Okay, it is generated by the hydroelectric power. Okay, so we know that. But how actually the electricity is produced, what we call that current, how it is produced, that we are going to learn in this chapter. A very, very interesting chapter if you understand it deeply. Okay, ತುಂಬಾ ಜನ ಈ ಚಾಪ್ಟರ್ಸ್ ಅನ್ನ ಯೂಶುವಲಿ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ನೋಡಿದ ತಕ್ಷಣ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆ ಫಾರ್ಮುಲಾಸ್ ನೋಡಿದ್ಮೇಲೆ ಏನಂತಾರೆ, ಮೇಡಮ್ ಐ ಕಾಂಟ್ ಡೂ ಇಟ್. ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಂದ್ರೆ ಅದನ್ನ ಅಟೆಂಡೇ ಮಾಡಲ್ಲ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ. ಬಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರುತ್ತೆ, ಅದರಲ್ಲಿರೋ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಓವರ್ ಆಲ್ ಅರೌಂಡ್ 7 ಮಾರ್ಕ್ಸ್, 6 to 7 ಮಾರ್ಕ್ಸ್ ನಮಗೆ ಈ ಒಂದು ಚಾಪ್ಟರ್ ಇಂದ ಬರುತ್ತೆ ಮಕ್ಕಳೇ. ಓಕೆನಾ? ಸೊ ಇಂಪಾರ್ಟೆಂಟ್ ಚಾಪ್ಟರ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇದರಷ್ಟು ಈಸಿ ಚಾಪ್ಟರ್ ನಿಮ್ಗೆ ಯಾವುದೂ ಇರೋದಿಲ್ಲ. ವೆರಿ ವೆರಿ ಇಂಟರೆಸ್ಟಿಂಗ್ ಚಾಪ್ಟರ್ ಅಂಡ್ ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಇನ್ PUC 1 ಆಲ್ಸೋ, PUC 2 ಆಲ್ಸೋ. ಯಾಕಂದ್ರೆ ಬೇಸಿಕ್ಸ್ ಇಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಆಗತ್ತೆ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಇದು. ಓಕೆನಾ? Yes, good evening everyone. Fine. So let us begin. Yes guys, electricity ಅಂತ ಹೇಳಿದ್ರೆ, okay, so electric current ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. The first one is electric current. So what do you mean by current? Can anyone tell me? Electric current ಅಂದ್ರೆ ಏನು? In your simple words, in your common words, you can tell me. What do you feel about current? What do you know about current? Yes? I am expecting answers in the comments, okay? Not the emojis. Yeah, tell me. What do you mean about, what do you know about electric current? Flow of charges. Who said it? Flow of charges. Uma Shankar. Very good. It is energy. Karthik said it. Okay. Jagadish answered it as the rate of flow of charges. Correct. Okay. Then I think my voice is clear. Something I got a message from CC. Anta, ma'am, voice is not clear. Anta. Whether my voice is clear, just let me know. If your network area is poor, you will not able to hear my voice properly. It supplies power, Vaishnavi. Okay. Pooja, current is power. Okay. Flow of power. Sinchana, don't know. It's okay. I am there to, I went there for you. You will get to know. Okay. Okay. Fine. So let us start. So electric current means what here? It is nothing but a flow of charges. Many of you said it is nothing but a flow of charges. Correct definition was given by Jagadish. So he said rate of flow of charges is called as current. So this is the exact definition. So now we will understand what is this exact definition is. Why we will call it as flow of charges. Why we will refer it as rate of flow of charges. That we will understand. So today's first sub-concept is electric current, its SI unit, okay, and its formula, as well as we are going to learn potential difference. Okay, guys. So let's begin. Just a minute. Yeah. So first of all, as I said, the rate of flow of charges is called as current. Then what is this charge? So see here, it is a fundamental property of matter because of which it experiences force. Any matter you take this pen, you take this laptop, your mobile, human beings, okay, you take anything, metal, copper, iron, anything. So every matter on this earth is made up of a tiny particles called as atoms. Okay, Paramanugalu. In Kannada, we will call it as Paramanugalu. I hope you all learnt about this atoms, right? So in ninth standard, do you remember we learnt structure of atom? Yes, guys, do you remember it? Structure of atom na kaltidvi nenpidena. Just let me know in the comment box. Yes, so I will let you know the SI unit of power. That also we are going to discuss. Okay. Of what? The central part of atom is called nucleus. Okay. So this nucleus will be having the positive charges. The nucleus will be having the positive charges. What are these positive charges are called as? Positive particles. Subparticles are called as what? ನ್ಯೂಕ್ಲಿಯಸ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಇರ್ತವೆ. ಆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ಎಸ್, just a minute. Yes, just check now whether my voice is clear.
Yes, ma'am.
Yes. So the okay, yeah. So the positively charged particles in the atom, as you all said, these are called as what? Protons. Fine. These are called as protons. Now tell me, around the positively charged particles, around the positively charged particles, that is around the nucleus, some orbitals are there like this. Okay, some circular or elliptical path will be there like this around the nucleus. Okay, so in this, we can find, okay, so in this, we can find a negatively charged particles. What are these negatively charged particles are called as? Can anyone tell me? Positively charged particles are called as protons. Then what about the negatively charged particles? Very good. Who said it? Electron. Nandini answered it. Then Vinuta answered it. Okay. Yeah. Very good. Neelu, Uma Shankar. So these are called as electrons. So whatever we call this electric current, now, this electric current is nothing but the flow of electrons. The flow of electrons is called as what? The electric current. It is a very nice, concept or a phenomena, my dear boys and girls. So actually what happens? So we know that the electric current will not flow in everything. For example, let me take this, my beads. Okay. So these beads are there, right? So in this, the electric current will not flow. In the glass, the electric current will not flow. But when I take a metal like copper, when I take a metal like iron, right? So in these all, the electric current will flow, right? So these things or these materials where electric current will flow are called as conductors. So usually most of the metals, whatever we see, these are conductors, means they allow the electric current to pass through them. Now the doubt arises, how they will conduct or how they will transfer the electric current, how they will allow the flow of electrons. So let us see how actually the electric current will form. Okay. So before that, so let us learn about the charges. As it is here, it is the fundamental property of a matter because of which it experiences the force, the flow of electric current. Then we have two types of charges. One is positive charge, one is negative charge. Since charge of an electron, that is a negatively charged particle, will be very less. What is the charge here? 1.6 into 10 raised to minus 19 coulomb. Coulomb is a SI unit of charge. Okay, so that is why only by one electron the electric current will not be generated because the charge is very less. So that is why the flow of electrons makes the electric current. So let us learn more about it, how the flow of electrons occur. Okay. So as we learned regarding conductors and insulators, conductors are the materials through which the flow of current occurs. Okay, so here we know that matter is made up of atoms, we know it, and each atom has a positively charged nucleus at the center and a negatively charged electron revolving around it, as you can see here. This is a positively charged nucleus and this is a negatively charged electron. Negative charged electron is bound to positively charged nucleus because of its charge. So here the electron is negatively charged. The proton is positively charged. So usually the opposite charges attract. So some force will be created which is called as electrostatic force. So due to that, the electron will be revolving around the nucleus. Fine. After that, when we provide external energy like heat or electricity, okay, so what happens there? The electron will gain the energy because the electron will be outside. It will be revolving around the nucleus. So the electron in the last orbit, what we can valence shell, valence electron ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಅಲ್ಲಿರೋ ಎಲೆಕ್ಟ್ರಾನ್. ಎಸ್ ಬಾಬು, KLMN ಶೆಲ್ ಅಲ್ಲಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ನಾವು ಕಾಪರ್ ಅಂತ ತಗೊಂಡ್ರೆ, ಸೊ ಕಾಪರ್ ಅಲ್ಲಿ ಯಾವ್ದು ಬರುತ್ತೆ, ಎಂ ಶೆಲ್ ಲಾಸ್ಟ್ ಬರುತ್ತೆ, ಹೌದಾ? ಸೊ ಲಾಸ್ಟ್ ಶೆಲ್ ಇರೋ ಎಲೆಕ್ಟ್ರಾನಿಗೆ ಇಫ್ ಯು ಪ್ರೊವೈಡ್ ಎನಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಎನರ್ಜಿ, ದಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಟೇಕ್ ದಟ್ ಎನರ್ಜಿ ಅಂಡ್ ಇಟ್ ವಿಲ್ shift to the other atom. It will jump to the next atom. So this shifting or the movement causes electric current. See here, if we provide energy to electron, it will not remain bound to the nucleus and just come out of an atom. So this type of electron which gets the energy and come out from the atom is called as free electron. Why free? Because it is not bounding. It is not binding with the nucleus, what we say. Okay. So this free electrons will start to move. So this movement of free electron forms the electric current. Okay. So yeah. So let me show you how actually the electric current will be formed. Okay. See, let us consider this as a conductor. Okay. So this conductor, it is made up of a copper. Let's just consider this is our copper conductor. Fine. So this copper conductor is made up of atoms. Which atoms? Copper atoms. Okay. So when we consider a single copper atom, when we consider a single copper atom, so these are this conductor is made up of atoms like this. Okay. Fine. Then, so the atom will be having the proton at the center and the electron which is revolving around it. Electron. Right. Again, electron, electron. Free electron in the valence shell I am marking. Electron in the last shell I am marking. Okay. So at the center, nucleus with proton. Okay. Then, so when you provide external energy, when you give external energy to the conductor, so what happens? This electron will absorb the energy and it will shift to the next atom. Same way, the movement of electrons, the movement of free electrons occurs. So this flow of movement of free electrons in a conductor forms or give rise to electric current. So what is the electric current? The rate of flow of charges, what we call. The rate of flow of charges is called as electric current. So now we understood flow of charges. So what is this rate? Rate means within a, what we can say, yeah, within a confined time, within this much of time, how many charges have been flowed? How many charges have been passed? So this is called as what? Electric current. Fine. So see here, flow of free electron through a conductor in a given direction is called as electric current. So here, the SI unit of electric current is ampere or A. Why? Because it is discovered by, or it is given by a scientist named Andrew Ampere. Okay. Then electric current. When we come to the formula of electric current, rate of flow of charges. So the charge will be given by a Q. This is charge Q. And rate per time is called as what? Our electric current. Fine. Then the SI unit of charge is coulomb. I is equal to Q Q by T. The SI unit of charge is coulomb, right? And the SI unit of time is second. So we can also refer or give the electric current SI unit as coulomb per second, or we can say ampere. Sometimes in exam they will ask define 1 ampere. I'm sorry. How will you define 1 ampere? So suppose when we consider I is equal to 1 ampere. Okay, so I is equal to Q by T. Q by T. So now here I should get 1 ampere means here the charge should be 1 coulomb divided by 1 second. So how can I define 1 ampere? The flow of 1 coulomb of charge in 1 second gives 1 ampere of electric current. The flow of 1 coulomb of charge in 1 second gives 1 ampere of current. Okay, so this is about what is 1 ampere and electric current. Fine. Okay. See, now we have mechanism of flow of charges. So see here, this, just a minute. Okay, fine. So mechanism of flow of charge, as I said you earlier, okay. Okay. Yes, Bhagya. Very nice question. Ma'am, how current passes in humans when he gets a shock? So when he gets a shock, the external energy is applied through the electricity. So that electricity will make the atoms inside us. So we are also made up of atoms, right? So the atoms which have electrons inside us, that will get excited. Excited andre ಆ ಎನರ್ಜಿಯನ್ನ ಪಡೆದುಕೊಂಡು ಅವೇನ್ ಮಾಡ್ತವೆ ಮೂವ್ಮೆಂಟ್ ಅನ್ನ start ಮಾಡ್ತವೆ. So this movement make us to feel shock. That is the movement of current occurs in our body. So that might be the phenomenon. Okay, that might be the phenomenon. So now let us come to the topic. Going by the same logic that we have understood from the activity. So let us consider a conductor which will be having millions of free electrons. Then there is no space for the additional electron. If we want to add extra electron, there is no space for them. So it means that when we push an additional electron into one conductor from one end, an electron would come out from the another end. For example, ಈಗ ಏನ್ ತಿಳ್ಕೊಳ್ಳೋಣ, ನಿಮ್ಮ ಸ್ಕೂಲ್ ಅಲ್ಲಿ ಬೆಂಚಸ್ ಇರ್ತವೆ. ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ 3 people can sit on that bench. So I will tell another person to sit. So he will sit. I will tell another person to sit. He will sit. So maximum 5 members have been sat on that bench. Not so comfortably, but they sat. If I want one more person to come and sit, so what will happen now? One person has to get up. Okay, so like this, the flow of electron will occur. Addition and one is moving. The extra one is moving. Addition, extra one is moving. Okay, so this happens instantly. It means that there is no time gap between pushing an electron and getting the electron out of the conductor. So this movement of electron forms the electric current in the conductor. Okay, then Then I told you about ampere. Then we have emitter. So what is this emitter? I hope you have seen emitter in your science laboratories. If you didn't, you can see it once you go to the school. So this is the emitter device, how it looks. So emitter is a device which is used to measure the electric current in the circuit. Means how much of electric current is there in the circuit. So that will be measured by this ampere, what we can say. And its symbol is A. Its symbol is A. Like this we will represent it in the circuit. See here, this is a circuit what we can see. And here the wires are connected to the ampere. So which shows that it measures the electric current. Okay. Now, fine. So see here, it is a device used to measure current in the circuit. Next, it is always connected in series with the resistor. So here, what is resistor? We will learn in this chapter. So don't worry about resistor here. ಇದು ರೆಸಿಸ್ಟರ್. ಈ ರೀತಿ ರೆಸಿಸ್ಟರ್ ನ ನಾವೇನ್ ಮಾಡ್ತೇವೆ, ಸಿಂಬಲೈಸ್ ಅಥವಾ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೇವೆ, ಗುರುತಿಸ್ತೇವೆ. ಸೊ ರೆಸಿಸ್ಟರ್ ಗೆ ಇನ್ ಸೀರೀಸ್ ಆಗಿ ಆಗಿ ಇದು ನೋಡಿ ಈ ರೀತಿ ಸೀರೀಸ್ ಆಗಿ ಅದನ್ನ ನಾವು ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೇವೆ. ಐ ವಿಲ್ ಟೆಲ್ ಯು ಅಬೌಟ್ ಸೀರೀಸ್ ಅಂಡ್ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ವೆನ್ ವಿ ವಿಲ್ ಬಿ ಡಿಸ್ಕಸಿಂಗ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಓಕೆ. ದೆನ್ ಇಟ್ ಹ್ಯಾಸ್ ಅ ವೆರಿ ಲೋ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಅಂದ್ರೆ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂದ್ರೆ ಏನು? ಅಪೋಸಿಷನ್ ಟು ದ ಫ್ಲೋ ಆಫ್ ಕರೆಂಟ್. ಸೊ ಅದಕ್ಕೆ ಅಪೋಸಿಷನ್, ಅದ್ರ ಒಳಗಡೆ ಇಂಟರ್ನಲ್ ಏನಿರತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ನಾಟ್ ಅಪೋಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಮಚ್. It will allow the electric current to pass. Then positive terminal of emitter is connected to positive side of the circuit. Negative terminal of the ammeter is connected to negative side of the circuit. That you should be knowing. Okay. Next. Next we have is direction of convention current anta. Andre ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗತ್ತೆ? Yes. Fine. So now tell me, what is the formula for current? Can anyone tell me in the comment box? What is the formula of current? Mariappa, I did not understand your question, my dear boy. So here, which depends on electrical resistivity on a given metallic wire. Many factors will influence the resistivity. Many factors are there. So please give, tell me the exact question. Yeah. So what is the formula of current? Anyone? Q by T. Very good. Who said it? Pooja, Mainaka, then Dhruva. Very good. Bhuvana, fine. Rajappa, Salim, Tippeswamy, Drona, very good. So Q by T. Then what is the SI unit of charge? What is the SI unit of charge? SI unit of charge I am asking. Okay. Q by T is the formula of current. Exactly. What is the SI unit of charge? Charge kelta idini. Prabhavati, you are answering the SI unit of current. I am asking SI unit of charge. No, Vasanta. Vasanta Goraguddi. Okay, it is not ampere. SI unit of current is ampere. Shadow strike, Coulomb. Hema Shiva Kumar Swami. Savita Bhatt, very good. So Coulomb is the SI unit of charge. Second is a SI unit of time. Ampere is a SI unit of current. Now we understood how the electric current is formed. How it is formed? By the flow of electrons. So in which direction the electrons will flow? So that we will understand. Since the free electrons are not bound to any particular nucleus, they can move freely within the conductor. But by convention, by our understanding, convention andre by our understanding, by our hypothesis, by our thought, okay, the flow of positive charges is considered to be the direction of current through the conductor. The direction of conventional current is opposite to the flow of free electron through the conductor. Just a minute. See, free electrons we know, they will be moving freely. They are not binded to the nucleus. Okay. So then, what about the opposite charges? The positive charges will be also there. So always the positive charges will want to collide with the electrons. So they will be always moving in the opposite direction. So here you can see the flow of positive charges will be in the direction of current. Direction of current andre ಏನು? Direction of flow of charges. ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಯಾಕಿರತ್ತೆ? ಬಿಕಾಸ್ ಅಪೋಸಿಟ್ ಚಾರ್ಜಸ್ ಅಟ್ರಾಕ್ಟ್. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕನ್ವೆನ್ಷನ್ ಕರೆಂಟ್ occurs. Okay. Next we have, okay. So now in the circuit, to initiate or to start the flow of charges, we will use battery or an electric cell. So these are the devices which are used to make the flow of charges through a conductor. So here you can see, in order to pass the charge through a conductor, we have to push additional charge from one end at the same time. So conductor ಅಲ್ಲಿ charges flow ಆಗಬೇಕು ಅಂದ್ರೆ additional ಆಗಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗ್ಬೇಕಾ? ಆ additional ಆಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋದ್ಮೇಲೆ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿರೋ ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದು ಹೊರಗಡೆ ಬರುತ್ತೆ. ಸೊ ಅಡಿಷನಲ್ ಆಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವ ರೀತಿ ಹೋಗ್ಬೇಕು? ವಿ ಕೆನಾಟ್ ಆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಲೈಕ್ ದಿಸ್. ಅದು ತಗೊಳಪ್ಪ, ಇದು ಕಾಪರ್ ಅಂದ್ರೆ ವಿ ಕೆನಾಟ್ ಆಡ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಲೈಕ್ ದಿಸ್. ಏನ್ ಮಾಡ್ಬೇಕು? ಅದಕ್ಕೆ ಅಡಿಷನಲ್ ಒಂದು ಡಿವೈಸ್ ಅನ್ನ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. ಎಂಥ ಡಿವೈಸ್ ಅಂದ್ರೆ, ದಟ್ ಡಿವೈಸ್ ಹ್ಯಾಸ್ ಟು ಗಿವ್ ದ ಎಲೆಕ್ಟ್ರಾನ್, ಅಡಿಷನಲ್ ಎಲೆಕ್ಟ್ರಾನ್, so that one electron from this will move out, which causes the flow of electron. So our device ಗೆ we will call it as battery or a electric cell. Okay. Next we have, then what is battery? How can you define the battery? See here, when two or more electric cells are connected in series. Electric cell andre ಏನು? It is simple. One positive charge will be there, one negative charge. So this is negative and this is positive. This is a symbol of battery cell, electric cell. ಸೊ ಇದೇ ರೀತಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಸೆಲ್ಸ್, ತುಂಬಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಸೆಲ್ಸ್ ಗಳನ್ನ ನಾವು ಇದೇ ರೀತಿ ಜೋಡಣೆ ಮಾಡಿದಾಗ, ಸೊ ಇಟ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ or it is called as what? Battery. Okay. Then battery or an electric cell will be having two ends, my dear friends. Okay. One is a positive end or a positive terminal. The other is negative end or a negative terminal. ಈಗ ಪಾಸಿಟಿವ್ ಎಂಡ್ ಇದೆ ಅಲ್ವಾ? ಸೊ ದ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ means what is here? End. ಹೌದಾ? ಸೊ ಪಾಸಿಟಿವ್ ಎಂಡ್ ಇಸ್ ನೋನ್ ಆಸ್ ಹೈ ಪೊಟೆನ್ಶಿಯಲ್ ಎಂಡ್ ಅಂತ ಕರಿತೀವಿ. ಯಾಕೆ ಅಂದ್ರೆ ಬಿಕಾಸ್ ಆಫ್ ಇಟ್ಸ್ ಹೈ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ. ವಿ ವಿಲ್ ಲರ್ನ್ ಅಬೌಟ್ ಪೊಟೆನ್ಶಿಯಲ್ ನಾವ್. ವೈ ನೆಗೆಟಿವ್ ಎಂಡಿಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ಲೋ ಪೊಟೆನ್ಶಿಯಲ್ ಅಂತ ಕರಿತೀವಿ, ಬಿಕಾಸ್ ಆಫ್ ಇಟ್ಸ್ ಲೋ ಎನರ್ಜಿ. ಅದರ ಹತ್ರ ಎನರ್ಜಿ ಲೋ ಇರತ್ತೆ. ದಟ್ ಈಸ್ ವೈ ಇದಕ್ಕೆ ಲೋ ಪೊಟೆನ್ಶಿಯಲ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ? ಫೈನ್. ಸಿ, ಇಫ್ ಸಮ್ವನ್ ಆಸ್ಕ್ಡ್ ಮಿ ಅ ಡೌಟ್, ನಾನು ಕ್ಲಿಯರ್ ಮಾಡಿರ್ತೇನೆ, ನಾನು ನೋಡಿದ್ರೆ ಆ ಕಮೆಂಟ್ ಅನ್ನ. ಸೊ ಕ್ಲಿಯರ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಯ್ತೋ ಇಲ್ವೋ ಅಂತ ಪ್ಲೀಸ್ ಅಗೇನ್ ಮೆನ್ಷನ್ ಮೀ ಇನ್ ದ ಕಮೆಂಟ್. ಓಕೆ. ದೆನ್ now we have the next concept, that is electric potential or potential difference. Very interesting concept. Electric current ನೋಡಿ, ಆ ಡೆಫಿನಿಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇದೆ. ರೇಟ್ ಆಫ್ ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜಸ್ ಯಾವ ರೀತಿ ಫ್ಲೋ ಆಗತ್ತೆ? ಒಂದ್ ಎಕ್ಸ್ಟ್ರಾ ಎಲೆಕ್ಟ್ರಾನ್ ಬರತ್ತೆ, ಅದಕ್ಕೆ ಜಾಗ ಇರೋದಿಲ್ಲ, ಸೊ ಇದರಲ್ಲಿರೋ ಎಲೆಕ್ಟ್ರಾನ್ ಹೊರಗಡೆ ಹೋಗುತ್ತೆ. ಸೊ ಈ ಮೂವ್ಮೆಂಟ್ ಏನಿದೆ ಇದು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್. So like this we will get the electricity. So let us now learn about electric potential ಅಥವಾ potential difference ಅಂತಾನು ಹೇಳ್ತೀವಿ. ಶಂಕರ್ H, how battery passed ಅಂದ್ರೆ ಗೊತ್ತಿಲ್ಲ ಅಪ್ಪ. I did not get your question, Shankar. How battery is passed andre I don't know. What is the meaning? I am not getting it. Okay. ಹ್ಮ್ Anjali, as I mentioned in the starting of the class, rate of anta ಬಂದ್ರೆ ಯಾವುದೇ definition ಅಲ್ಲಿ rate of ಅಂತ ಬಂದ್ರೆ that we are calculating according to the time. For example, let us consider this as a copper conductor. ಹೌದಾ? So the charge in 1 second, the flow of charges is 10. 10 charges flow ಆಗಿದೆ. So 1 second ಅಲ್ಲಿ ಇಷ್ಟು charges flow ಆಗಿದೆ. That gives you electric current. Rate means what? The flow of charges per unit time. ಇಷ್ಟು ಟೈಮ್ ಅಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಫ್ಲೋ ಆಯ್ತು ಆ ಟೈಮ್ ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತಲ್ವಾ. ಸೊ ದಟ್ ಟೈಮ್ ವಿ ವಿಲ್ give the term or use the word rate of. Understood, Anjali? Please comment in the comment box. And the battery ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಜನಕ್ಕೆ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂತ ತಿಳ್ಕೊತೀನಿ. ಬ್ಯಾಟ್ರಿ ಅಂದ್ರೆ ನೋಡಿ ಮಕ್ಕಳೇ, ಸೆಲ್ ಅನ್ನೋದು ನೆನಪಿರ್ಲಿ ನಿಮ್ಗೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಸೆಲ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಸೆಲ್ ಅಲ್ಲಿ ಎರಡು ಎಂಡ್ಸ್ ಗಳು ಇರ್ತವೆ. ಒನ್ ಇಸ್ ಪಾಸಿಟಿವ್ ಎಂಡ್ ಅಂಡ್ ಒನ್ ಇಸ್ ನೆಗೆಟಿವ್ ಎಂಡ್. So this electric cell, for the big circuits, we cannot use this electric cell because its energy will be low. ಹೌದಾ? ಸೊ ಅದಕ್ಕೆ ನಾವೇನ್ ಮಾಡ್ತೇವೆ, ವಿ ವಿಲ್ ಟೇಕ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಸೆಲ್ಸ್ ಲೈಕ್ ದಿಸ್ ಅಂಡ್ ವಿ ವಿಲ್ ಕನೆಕ್ಟ್ ಒನ್ ಟು ಒನ್ ಅನದರ್. ಒಂದಕ್ಕೊಂದು ಜೋಡಣೆ ಮಾಡ್ತೇವೆ. ಸೊ ದಿಸ್ ಕನೆಕ್ಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಸೆಲ್, this group of electric cell forms the battery, which has extra energy, high energy. Okay, so this battery will be also having two end. One is positive end, one is negative end. Okay, so what this battery will do, it will give additional energy to the conductor. ಯಾಕೆಂದ್ರೆ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಏನಾಗ್ಬೇಕು, ಫ್ಲೋ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗ್ಬೇಕಾ, ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜಸ್ ಆಗ್ಬೇಕಾ. ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜಸ್ ಆಗ್ಬೇಕಂದ್ರೆ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಶುಡ್ ಬಿ ಆಡೆಡ್ ಎಕ್ಸ್ಟ್ರಾ ಹಿಯರ್. ಸೊ ಈ ಎಲೆಕ್ಟ್ರಾನ್, ಎಕ್ಸ್ಟ್ರಾ ಎಲೆಕ್ಟ್ರಾನ್ ನ ಎಲ್ಲಿ ತರ್ತೇವೆ? ವಿ ವಿಲ್ ನಾಟ್ ಆರ್ಡರ್ ಇಟ್ ಫ್ರಮ್ ಝೊಮ್ಯಾಟೊ, ಸ್ವಿಗ್ಗಿ, ಆರ್ ವಿ ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಇಟ್ ಫ್ರಮ್ ಶಾಪ್. ಸೊ ಅದಕ್ಕೆ ನಾವು ಬ್ಯಾಟ್ರಿಯನ್ನ ಕನೆಕ್ಟ್ ಮಾಡ್ತೇವೆ. ಸೊ ಅದೇನ್ ಮಾಡತ್ತೆ, ಅಡಿಷನಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಕೊಡತ್ತೆ. ಸೊ ಈ ಅಡಿಷನಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಕಂಡಕ್ಟರ್ ಒಳಗೆ ಹೋದಾಗ ಇದ್ರಲ್ಲಿರುವ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗ್ತವೆ, ಜಾಗ ಸಾಕೋಗೋದಿಲ್ಲ. ಸೊ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಕಮ್ ಔಟ್. ಸೊ ಇದೇ ರೀತಿ ಅಡಿಷನ್ ರಿಮೂವಲ್, ಅಡಿಷನ್ ರಿಮೂವಲ್. So this forms the movement of electron. Like this, the electric current will be formed. Okay, ಇದನ್ನ ಯಾರು ಕೇಳಿದ್ರು? Ravish. I hope I answered your question. Ravish, okay? Yeah. So let us proceed with the electric potential and potential difference anta. Okay. Yeah. Yes, Rani, good night. You can sleep. I'm not telling you not to sleep. Yeah. So the ability of a battery's terminal to push a unit charge into the conductor is called as electric potential. So I said you about battery, alva. So battery ಏನ್ ಮಾಡತ್ತೆ, ಪುಷ್ ಅ ಯೂನಿಟ್ ಚಾರ್ಜ್, ಒಂದು ಚಾರ್ಜ್ ಅನ್ನ ಕಂಡಕ್ಟರ್ ಒಳಗ್ ಹಾಕತ್ತೆ. ಸೊ ಆ ಒಂದು ಚಾರ್ಜ್ ಅನ್ನ ಕಂಡಕ್ಟರ್ ಒಳಗ್ ಹಾಕೋದಕ್ಕೆ ದಟ್ ಎಬಿಲಿಟಿ ಆಫ್ ದಟ್ ಬ್ಯಾಟ್ರಿ ಇದೆ ಅಲ್ವಾ, ದಟ್ ಕೆಪಾಸಿಟಿ. So that is called as electric potential of that battery. Okay, now, so the difference of electric potential between positive and negative terminal of a battery defines battery's power. ನಾನು ಅವಾಗ್ಲೇ ಹೇಳಿದೆ, ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಹೈ ಪೊಟೆನ್ಶಿಯಲ್, ಅಂದ್ರೆ it will be having high ability to push a additional charge. Okay, negative terminal alli it will be having low capacity, low ability to push or pull a charge. Okay, see here, battery power ಯಾವ ರೀತಿ ನಾವು ಡಿಫೈನ್ ಮಾಡಬಹುದು ಅಂತಂದ್ರೆ, ಎಷ್ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಇದೆ ಪಾಸಿಟಿವ್ ಮತ್ತೆ ನೆಗೆಟಿವ್ಗೆ. ಸೊ ಅದರ ಡಿಫ್ರೆನ್ಸ್ ನಮಗೇನ್ ಕೊಡತ್ತೆ, ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫ್ರೆನ್ಸ್ ಅನ್ನ ಕೊಡತ್ತೆ. Okay, so let me explain you in this way. See here, potential difference we will also called as voltage anta. ಅದಕ್ಕೆ ನಾವು voltage ಅಂತಾನು ಕರಿತೇವೆ. So you might be heard about this term in your home. ವೋಲ್ಟೇಜ್ ಜಾಸ್ತಿ ಆಗಿದೆ, ವೋಲ್ಟೇಜ್ ಕಮ್ಮಿ ಇದೆ, ಅದಕ್ಕೆ ಕರೆಂಟ್ ಬರ್ತಾ ಇಲ್ಲ, ಈ ರೀತಿ ಏನ್ ಮಾಡ್ತಿರ್ತಾರೆ, ಹೇಳ್ತಿರ್ತಾರೆ. ಸೊ ಈ ವೋಲ್ಟೇಜ್ ಅಂದ್ರೆ ಏನು? ಅದು that is nothing but our potential difference we can call. So how we can define voltage andre, it is between any 2 points, it is defined as work done in moving a unit charge from one point to another. Now let us consider our copper conductor. Fine. So this copper conductor is connected to a battery. Okay. So this battery will provide what? It will provide the extra charge, or it will push a electron from it to the conductor. Just a minute. Yes. So it will push the electron. This battery will push the electron through the conductor. So this makes one electron to come out of the conductor. Okay. So the potential difference means what? This is first point. This is second point. So this charge should come. This charge from the battery should come from this point. That is from the point 1 to point 2. So the work done to in moving a unit charge means a single electron from one end to another end. How much work done? ಎಷ್ಟು ಕೆಲಸ ಆಗಿದೆ? ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಒಂದು ಎಂಡಿಂದ ಇನ್ನೊಂದು ಎಂಡಿಗೆ ತಗೊಂಡು ಹೋಗುವಾಗ ಎಷ್ಟು ಕೆಲಸ ಆಗಿದೆ? ಆ ಕೆಲಸಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ವೋಲ್ಟೇಜ್ ಅಥವಾ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಂತ ಕರಿತೇವೆ. So we can give, or we can tell the formula of potential difference as V is equal to W by Q. What is W here? It is work done. Work done in what? Work done in carrying the unit charge, a single electron, okay, from one end to another end. So this will give us the potential difference, or we can also say it as voltage. Okay, see here. SI unit of voltage is volts. Voltage between 2 points is said to be 1 volt when 1 joule of work is done in carrying 1 coulomb of charge. So voltage na ನಾವು ಯಾವಾಗ 1 ವೋಲ್ಟ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತೇವೆ? ಯಾವಾಗ 1 coulomb of charge, ಓಕೆನಾ, 1 coulomb of charge ಒಂದು ಎಂಡಿಂದ ಇನ್ನೊಂದು ಎಂಡಿಗೆ ಹೋಗುವಾಗ 1 joule of work is happened. Work done means what? Work andre ಏನು? Capacity of a energy is called as what? Work done. ಹೌದಾ? So ಈಗ if we consider this as our copper conductor, this electron is moving from end A to end B. Okay. So when the charge of this electron is 1 coulomb and the work done from transferring this electron from point A to point B is 1 joule, okay, then we will call the voltage or potential difference as 1 volt. Okay, so like this we will define the potential difference. Fine. Next, now we have regarding the voltmeter. Can anyone tell me which is a device used to measure current? Which is a device used to measure current? Yes, tell me. Very good. Yamuna Shetty, Uma Shankar. ಕರೆಂಟ್ ಕೇಳ್ತಾ ಇದ್ದೀನಿ. ರೋಹನ, ಶ್ರೀಕಾಂತ್ ಗೌಡ. ಎಸ್. ಪ್ರಭಾವತಿ. ಕಿಶೋರ್, ಐ ವಿಲ್ ಆನ್ಸರ್ ಯುವರ್ ಕ್ವಶನ್. 3 ಸಲ ಹೇಳ್ದೆ ನಾನು ಆಲ್ರೆಡಿ. ನೀವು ಲೇಟ್ ಆಗಿ ಅಟೆಂಡ್ ಆದ್ರಿ ಅಥವಾ ನಾನು ಹೇಳುವಾಗ ನಿಮಗೆ ಯು ಆರ್ ನಾಟ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಅನ್ಸುತ್ತೆ. ಐ ವಿಲ್ ಟೆಲ್ ಯು. Okay, so to measure the current, we will use a device called ammeter. Okay, so to measure the potential difference, we will use a device called voltmeter. It looks like this. Fine. So it is a device used to measure voltage across the resistance in the circuit. Okay. It is always connected parallel. So you'll know it. Parallel lagi it will be connected to the resistor. I will say you parallel and series connection yav reeti anta. It has a very high internal resistance, means it will not allow the electric current to pass through it very easily. Then positive terminal of voltmeter will be connected to positive side, negative end will be connected to negative side. Okay. Now we understood what is electric current. Now we understood what is potential difference. So now we will put all these concepts and now we will understand how actually the bulb glows. So just to see a bulb in your room and now we will understand how this actually happens. You can see the circuit in the diagram. See here, when the circuit is turned on, and I mean when you switch on, okay, the positive terminal, which is rich in positive charge of the battery, which will be having high potential or high energy, pushes positive charge. So, ನೀವು switch on ಮಾಡಿದಾಗ positive end of battery ಏನ್ ಮಾಡುತ್ತೆ positive charges ಅನ್ನ ಫ್ಲೋ ಮಾಡುತ್ತೆ, push ಮಾಡುತ್ತೆ through the wires. ಹೌದಾ? ಈ ರೀತಿ ನೋಡಿ, ಇಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆ ನಿಮ್ಗೆ. Let me take the laser point. Okay, see here. This is a positive charges. A big line always indicates positive end. A small line always indicate negative end. Remember it. Okay. So when you switch on, the positive end of a battery will push positive charges with a great energy through the wires. Fine. At the same time, ಅದೇ time ಅಲ್ಲಿ ಈ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಇದೆ ಅಲ್ವಾ, ಈ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್, okay, it will push what? Negative terminal, deficiency of positive charge of a battery, which is at low potential, pulls positive charge from the bulb because of polarity through connecting wire. So ನಾವೇನ್ ಅನ್ಕೋತೇವೆ, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಫ್ಲೋ ಆಗ್ತವೆ ಅಂತ ತಿಳ್ಕೊತೇವೆ. ಬಟ್ ಆಕ್ಚುಲಿ ಡ್ಯೂ ಟು ದ ಹೈ ಪೊಟೆನ್ಶಿಯಲ್ ಇಲ್ಲಿ ಪೊಲಾರಿಟಿ ಕ್ರಿಯೇಟ್ ಆಗಿ ಏನಾಗಿರುತ್ತೆ, ಸೊ ಇಟ್ ಆಲ್ಸೋ ಪುಷಸ್ ದ what we can say is positive charges. So this act of pushing charge through the positive terminal at the same time withdrawing same amount of charge through negative terminal. ಇಲ್ಲಿ ನೋಡಿ, ಎಷ್ಟು ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಇಲ್ಲಿ ಹೋಗ್ತಾ ಇದಾವೋ ಅಷ್ಟೇ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಪೊಲಾರಿಟಿ ಆಗಿ ಈ ಕಡೆ ನೆಗೆಟಿವ್ ಎಂಡಿಗೆ ಬರ್ತಾ ಇದ್ದಾವೆ. ಸೊ ನಂಬರ್ ಆಫ್ ದಿಸ್ ಚಾರ್ಜಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ನಂಬರ್ ಆಫ್ ದಿಸ್ ಚಾರ್ಜಸ್. ಓಕೆ, ಸೊ ದಿಸ್ ವಿಲ್ ಕಂಪ್ಲೀಟ್ ದ ಸರ್ಕ್ಯೂಟ್. ನೆಕ್ಸ್ಟ್, as the circuit becomes complete, yavaga circuit complete agatto, that is the rate of charges flowing from this potential will equal to the rate of charges coming to this potential or this end. So avaga enagatte, the bulb will glow. It means that we cannot make a bulb glow by connecting it only to the positive terminal. ಈಗ ನಮಗೆ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಇಂದ ಜಾಸ್ತಿ ಚಾರ್ಜಸ್ ಬರುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಂಡು ಓನ್ಲಿ ನೀವು ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ಗೆ ಅದನ್ನ ಅಟ್ಯಾಚ್ ಮಾಡಿದ್ರೆ ಬಲ್ಬ್ ವಿಲ್ ನಾಟ್ ಗ್ಲೋ. ವೈ? ಬಿಕಾಸ್ ದ ಸರ್ಕ್ಯೂಟ್ ಇಸ್ ನಾಟ್ ಕಂಪ್ಲೀಟೆಡ್ ಅಲ್ವಾ. ದೆನ್ ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ರಿಯೇಟ್ ಅ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್. ಸೊ ವೆನ್ ಯು ಕನೆಕ್ಟ್ ಬೋತ್ ದ ಎಂಡ್ಸ್, ದಟ್ ಈಸ್ ಪಾಸಿಟಿವ್ ಅಂಡ್ ನೆಗೆಟಿವ್, potential difference will be connected there, because this is of low potential, this is of high potential. So which creates potential difference, which makes the circuit complete, and then our bulb glows. So like this, glowing of bulb will occur. Okay. So now this is about the glowing of the bulb. Now we have the most important concept of electricity here, which is called Ohm's law. Okay. So see here what actually Ohm's law tells, we will discuss now. We have to create a potential difference across a conductor by connecting it to a battery if current is to flow through the conductor. So now to explain, to get to know about Ohm's law, we have to do it. What we have to do? We have to create a potential difference across a conductor. We should take a conductor which is connected to a battery like this. Okay. Okay, then it should have a potential difference, that is positive and negative. So the amount of current passing through the conductor depends upon the potential difference. So how much amount of current will flow through this conductor? That is, current means what? I. It depends on the potential difference between these two ends. So what actually Ohm's law states is, it states that current through a conductor or a wire is directly proportional to potential difference across the conductor. Means if I is directly proportional to V, Ohm's law tells us that I is directly proportional to V. This sign indicates directly. ನೇರ ಅನುಪಾತದಲ್ಲಿ, ನೇರಾನುಪಾತದಲ್ಲಿ ಅಂತ ಕರಿತೇವೆ ಇಂಗ್ಲಿಷ್ ಅಲ್ಲಿ. ಹೌದಾ? ವಿಲೋಮಾನುಪಾತ ಅಲ್ಲ, ನೇರಾನುಪಾತದಲ್ಲಿ. ಅಂದ್ರೆ if potential difference increases, current increases. If potential difference decreases, current decreases. Okay, so that is why we will say directly proportional. So according to Ohm's law, how much ever current will flow, okay, so that is directly proportional to how much potential difference is there in that circuit. Mathematically, how we can say I is directly proportional to V. So ಈ ಸೈನ್ ಅನ್ನ ತೆಗೆದು ಹಾಕೋದಕ್ಕೆ, ಈಕ್ವಲ್ ಟು ಮಾಡೋದಕ್ಕೆ, we will say I is equal to V into R. Just a minute. Sorry. Okay. So let us come according to the statement, then you will understand. Otherwise, ulta agate adu. See here. It states that current through a conductor or a wire is directly proportional to potential difference. That is, V is directly proportional to I. V is equal to I into R. So, idanna remove ಮಾಡೋದಕ್ಕೆ proportionality constant ಅನ್ನ, proportionality sign ಅನ್ನ, we will replace it by equal to. So, ಆವಾಗ proportionality constant ಅಂತ ಬರುತ್ತೆ, which is nothing but our R. R refers to here resistance of a conductor. Resistance of a conductor. So, V is equal to IR is a Ohm's law. So, what Ohm's law states? The potential difference across a conductor is always proportional to the flow of current through it. Okay, so this is about Ohm's law. Most important law. You have to write the statement of the law as well as you have to write its mathematical form. So see here, provided temperature remains constant. So yavaga V is directly proportional to I agatte, yavaga temperature of the conductor constant ಆಗಿರುತ್ತೆ. It should not decrease or it should not increase. ಆವಾಗ ಏನಾಗತ್ತೆ? So, illi Ohm's law, that is potential difference, will always directly proportional to current flowing through the conductor. So, here you can see the current, okay, and here you can see the voltage. Fine. So, as the current increases, ee ರೀತಿ increase ಆಗ್ತಾ ಹೋದಂಗೆ, ಇಲ್ಲಿ ನೋಡಿ, ಇದು increase ಆಯ್ತಾ, ಇದು increase ಆಯ್ತು. So, as the current increases, what happens? The voltage will also increase. Slope ಬಗ್ಗೆ you will learn in PUC. Next. Now we have what is resistance of the conductor. So, ನಾವು Ohm's law ಅಲ್ಲಿ ತಿಳ್ಕೊಂಡ್ವಿ. ಏನಂತ? V is equal to I into R ಅಂತ. V is equal to I into R, where R is resistance. So, what is this resistance? It is nothing but it is also a property of a substance, of a conductor. ಅದು ಕೂಡ ಒಂದು ಕಂಡಕ್ಟರ್ ಅಥವಾ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ನ ಪ್ರಾಪರ್ಟಿ ಅಥವಾ ಗುಣಲಕ್ಷಣ ಅಂತ ತಿಳ್ಕೊಬಹುದು. ಏನ್ ಮಾಡತ್ತೆ ಅಂದ್ರೆ, ಸೊ ಯೂಶುವಲಿ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗ್ತಾ ಇರತ್ತಾ, ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜಸ್ ಆಗ್ತಾ ಇರತ್ತಾ. ಸೊ ದಿಸ್ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಸೇ ಪ್ರಾಪರ್ಟಿ It opposes the flow of charges. One property the substance which opposes the flow of charges. It will not allow the electric current to pass through it. So ಆ ಒಂದು ಪ್ರಾಪರ್ಟಿಗೆ ನಾವು resistance ಅಂತ ಕರಿತೇವೆ. So which obstruct the flow of charge through them. So ಈ ಒಂದು ಪ್ರಾಪರ್ಟಿಗೆ ನಾವು resistance ಅಂತ ಕರಿತೇವೆ. Okay. So its SI unit is ohm. So ಈ ರೀತಿ ನೀವು ನಮ್ಮ ಮನೆಯ ಸರ್ಕ್ಯೂಟ್ಸ್ ಗಳಲ್ಲಿ ಮೇನ್ ನಮ್ದು ಎಲೆಕ್ಟ್ರಿಕ್ ಸರ್ಕ್ಯೂಟ್ ಇರತ್ತಲ್ವಾ ಮನೆಯಲ್ಲಿ, ಸೊ ಅದರ ಒಳಗಡೆ ಯಾವಾಗದು ಫ್ಯೂಸ್ ಹೋದಾಗ, ಸೊ ಹಳೆ ಕಾಲದಲ್ಲಿ ಇದ್ದಾಗ ಈ ರೀತಿ ನೀವು ರೆಸಿಸ್ಟರ್ಸ್ ಗಳನ್ನ ನೋಡಬಹುದು. ಅಥವಾ ವೆನ್ ಯು ಗೋ ಟು ದ PUC, ಸೊ ದೇ ವಿಲ್ ಶೋ ಯು ದ ರೆಸಿಸ್ಟರ್ಸ್ ವಿಲ್ ಬಿ ಲೈಕ್ ದಿಸ್. ಸೊ ಕಂಡಕ್ಟರ್ಸ್ ಹ್ಯಾವ್ ವೆರಿ ಲೋ ರೆಸಿಸ್ಟೆನ್ಸ್. ನಾವೇನು ಮೆಟಲ್ಸ್ ಅಂತ ಕರಿತೇವೆ, which are very good conductors of electricity. So conductors ಅಲ್ಲಿ usually resistance ಅನ್ನೋದು, that is R ಅನ್ನೋದು ಕಡಿಮೆ ಇರುತ್ತೆ. Whereas insulators ಅಂತ ಏನ್ ಕರಿತೇವೆ, which will not allow electric current to pass. So insulators ಅಲ್ಲಿ resistance ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್, materials with zero or negligible resistance. ಯಾವ ಮಟೀರಿಯಲ್ಸ್ ಅಲ್ಲಿ ತುಂಬಾ ಕಡಿಮೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಥವಾ ಝೀರೋ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರ್ತಾವೋ, ಸೊ ದೋಸ್ ಕಂಡಕ್ಟರ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ಸ್. ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೇವೆ, ಸೂಪರ್ ಕಂಡಕ್ಟರ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ ನಾವು ಲೆಟ್ us learn about factors affecting the resistance. ಓಕೆ, ಸೊ ನಾವಿಲ್ಲಿ ನೋಡಿದಾಗೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ಓಮ್ಸ್ ಲಾ, V is equal to I into R. ಸೊ ನಮಗೆ R ಬೇಕು ಅಂದ್ರೆ I should go here. So here it is multiplication. When it comes here, it becomes division. So R is equal to V by I. ಹೌದಾ? ಸೊ ಕರೆಂಟ್ ಜಾಸ್ತಿ ಇದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಕರೆಂಟ್ ಕಡಿಮೆ ಇದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ರೆಸಿಸ್ಟೆನ್ಸ್ is always inversely, ವಿಲೋಮಾನುಪಾತದಲ್ಲಿ is always inversely proportional to current. Now, see, resistance is directly proportional to length of the wire. It means longer the wire has more resistance as compared to shorter wire. So when we consider two conductors or two wires, okay na? So the wire which has more length, no? So that wire will be having more resistance. Why? Because when the flow of electrons occurs, obstruction will be more, the collision will be more in the wire which has more length. So that is why when the length of a wire is more, the resistance will be more. Same way, resistance is inversely proportional to area of cross section. So when you consider this wire, no? Okay, so this is a length. Area of cross section means this surface. If the area of cross section is less, then resistance will be more. If the area of cross section is more, resistance is less. So R is directly proportional to L. R is inversely proportional to A. A means what? Cross area. Okay. So now mathematically how we can write the formula is R is equal to rho into L by A. L is length of the wire. A is cross area of the wire. And rho is resistivity, a constant. Okay, resistivity. So this resistivity will be constant for a material. For iron, resistivity will be different. For copper, resistivity will be different. For what we can say, tungsten resistivity is different. It depends on the material and it will be constant. It will not change. Okay. So this is about the resistance. R is equal to rho L by A. Okay. So tomorrow we will discuss this resistance and factors affecting the resistance in detail, as well as we are going to discuss the resistivity. Okay, resistivity and combination of resistors. Fine. So tomorrow don't miss the session. Okay. Tomorrow don't miss the session. Fine. Okay then. Let me end up the session here. Have a nice day. Take care. Bye-bye.